This is the second try at me teaching implicit for the camera. But here's the deal. Yeah, you can wait.
I can't see you.
Now, here's the deal. You've already been doing implicit and you just don't know it. But we're going to add a little bit more to it. And I'm going to show you why I'm saying you've already been doing implicit. You have y equals x cubed. And you're taking the derivative with respect to x. You write dy over dx, because that means I'm taking the derivative of y with respect to x equals 3x squared. That was your implicit differentiation right there, because y was implying a function, and dy over dx is the derivative of y. And then you did your what? 3x squared. All right? So far, so good. Now, if you wrote this, the x squared, well, let's talk about the y cubed. Y is implying a function. When you have y with a power above it, you're going to use the power rule. When you have y with a power above it, you are going to use the power rule because it implies a function. In other words, you pretend that there's a bunch of stuff in parentheses with a cube above it. So you bring the 3 to the front, write down the y squared, and then you have to do the du part. Remember, u cubed, and then the derivative of the y is dy over dx. Now, pretty cool, pretty easy, right? Yeah. Now, someone says, well, Mr. Evans, if you were taking the derivative of x, and you brought the x to the 2 to the front, then you wrote down the x, why didn't you put dx over dx out here?
1.
Yeah, you really did. It just equaled 1. See, this is the derivative of y with respect to x. So really, when you were doing this, you had the derivative of x with respect to x, which equaled what? 1. So you've been doing implicit all along. It's just that that always equals what? 1. Fair enough? Okay. Now later on, we take the derivative with respect to time or something. You would have dx over dt, or you could have dA over dt. But for right now, see, that would have been what? Dx over dx. That's the only reason we had to do it. Now, here we go. Let's say I had x cubed, y cubed, plus x plus y equals 1. Trying to make this a little bit long, so I'll show you a lot of information in one little part. I'm going to help you out with this first part. Oh, someone says, Mr. Evans, could we make them y equals and then take the derivatives? Don't do it. To start with, some of them would be very difficult to do, and then some of them you've got to really pay attention to what you're doing or you make mistakes. I'm going to show you that in a few minutes about why you want to know this. All right, put my dot right here. Trying to get you to see that this is a big old what? Product rule. What's the derivative of x cubed? 3x squared. Write down your y cubed plus. Write down your x cubed. And then when you take the derivative of your y cubed, okay, you got to take the derivative of the x cubed, 3x squared. Then you got to write down the second term plus. Write down the first term. And then 3y squared. And then don't forget dy over dx. That's your product rule. And then you're going to get a plus 1. Because that's going to be what? Dx over dx. And then you're going to get a plus what? Dy over dx equals 0. And I'll just go ahead and tell you the biggest problem with these is a lot of times they're going to equal a constant. And everyone leaves the constant out there instead of realizing the derivative of that constant is what? 0. Okay? That's the biggest mistake you'll make. People will get all of this right and then leave equal 1 out there. Yes, ma'am?
Why does that y turn into dy over dx?
Okay, because the derivative.
Okay.
Yeah, it's dy, the derivative of y with respect to x.
Okay.
That help?
Yes.
All right. Now, if you wanted, the next step might be to isolate the dy over dx by itself, right? That's all algebra. Subtract this from both sides, subtract the 1 from both sides. And I'm going to write it out step by step. I am not going to just go, that's algebra, and stop writing like your professor will in college. Because, I mean, this is just algebra. All right? Subtracted this one from both sides, subtracted that one from both sides. What can I'm going to factor out what? Dy over dx out of both of these, right?
Yes.
Is that okay? I'm going to factor it out. We'll get 3x squared, y squared, plus 1 equals, and then simply dy over dx is going to equal all of that over what? All of that.
You got some different shoes on today.
Yep, these are comfy. I had to wash all my tennis shoes after I planted trees this weekend and all that.
It's not x cubed 3y squared dy dx on the left.
It is x cubed. I quit writing the cube down. Thank you. I quit writing the cube down. See? That's the reason I shouldn't make videos. Now they're all, yeah, you missed that. So, dy over dx equals, and if you wanted to, is everyone okay that you can factor a -1 out of both of those so that it looked prettier? And I would change the denominator, make it 1 plus. Change the order just to make it look prettier. And there you go. And that's all algebra after the first step. And I'm just going to go ahead and tell you what's going to drive you nuts on implicit differentiation is the algebra. And what's the derivative of y with respect to y? X? dy over what? dx. The derivative of x with respect to x is 1. Changing x with respect to changing x. Happy? I want y'all to look at it real close and make sure you really are happy. I don't ask any of those questions at different levels. If you've got a question, you're going to ask. See, you answered your question yourself, which means you were thinking. You realize, oh yeah, that's a dy over dx. Or yeah, it's all a product rule in there. All right. Now we'll show you why we do implicit. Here we go. Sure?
Yes, sir.
Okay. Why do we do
Wait.
implicit?
Don't do the bottom part yet. Hold on.
Why are our pants kind of like some?
Oh no, because I got like 6 pair of these that I bought for $10 a piece, and I just wear them to school.
That's 60. Our pants are kind of, I can imagine what it is.
Yeah. See, they're comfortable.
Do you have any green ones?
No, because they were $15 if they were green. Just now. Yeah. It's the first day I've worn long pants since April of last year, or maybe March of last year.
Isn't that exciting?
No. No. I've walked in snow with short pants on before.
Okay.
Yeah. Now, that's all going on my implicit differentiation video. Good. Find out that, your teacher is human. All right, here's why we do implicit. We do implicit just to irritate you.
Yay.
Okay. See, I thought that would come out really well. All right, let's look at this. We're going to do y implicit. This, okay. If I had x squared plus y squared equals 25. Do y'all know what shape that is, what graph that is? What?
Circle.
That's a circle. Yeah, you've got to recognize those bits of information. This is a circle. Now,
You're like, what? What is that?
yeah, if you don't know it's a circle, I'm not going to say anything mean, but you should have somebody in pre-calc hit you harder. Oh, sorry. Didn't say that out loud either. Okay, now, I'm going to talk about the point 3, 4, and 3, negative 4, which are both on that circle. Now, points on the circle, yes, point. Okay, and just for fun, we're going to do the bad way in green. I wouldn't even write this way down.
Because green pants cost $15 instead of 10, so green is bad.
No, Captain Street.
Oh, yeah, that too, sorry.
Okay, Captain Street.
Don't be hating on the green pants.
Now, here's what the Captain Shreve student would do. The Captain Shreve student would not learn implicit differentiation. And they would rewrite this, y equals square root of 25 minus x squared.
They're the ones that are going to be watching these videos anyway.
No, they don't want to watch them. Y equals, parentheses, 25 minus x squared to the what? 1/2.
Maybe profits?
Yes, sir.
Why is it not square root of y equals square root of 25 minus x squared?
Because I took, okay, it's y squared, right? Took the square of this side, and I took the square root of,
Oh, I see.
okay? Now, that green ink got you. Then the Captain Shreve kid takes the derivative. And I'm going to put it over here, because I'm leaving the space over here to correct what he's going to do wrong. That's the reason this is the bad way. And he's going to get dy over dx equals 1/2 25 minus x squared to the negative 1/2 times negative 2x. Okay? Now, after that step, he's going to rewrite it so he can work with it, which is smart. He's one of the smarter Shreve kids. And he's going to get negative x over square root of 25 minus x squared. At this point, he is going to put the 3 in there to find the slope at 3. Is that okay? And when he puts the 3 in there to find the slope at 3, finds the slope at 3, he's going to get negative 3 over 4. And then, if he hadn't drawn the circle, he's going to think this one is also what? Negative 3 over what? 4. And it's not, is it? We can look at that and tell that the slope right there is not negative 3 over 4, right? Everybody here okay that the slope is not negative 3 over 4 there?
The slope where?
At this point.
Okay.
See? It's going to be a positive slope. Yeah. See, this one, yeah, you do get a negative slope. But this one you should get a what? Positive.
How do you know that?
How do you know it's a positive slope? Looking at it from left to right, is it going up?
As Ms. Joy says, if Jim slides down, it's going to be negative.
Okay, from left to right, is it going up?
Yeah.
It's a positive slope.
Okay.
We do not read from right to left.
We're not Japan.
Now, here we go. So, here's where our little child had the problem. If you were to do it this way, when you took the square root, you would have to realize that when you take a square root, it's not a principal square root, it can be what? Positive or negative. So you would have actually had to do a derivative for the positive square root, but you would have also had to come over here and done a derivative for the negative, which if you put the negative here, right, you're going to get dy over dx is equal to negative 1/2, parentheses, 25 minus x squared to the negative 1/2 times negative 2x. The negative is there because there should have been a negative there, right? Okay? So you had to do one for the positive, and you had to do one for the negative. And then we'll put a little or there.
Oh, no.
Then dy over dx would equal a positive x over the square root. And that is the reason we don't want to rewrite them. Now, so this would be the one you would use if y was negative, right? Okay? You'd have to use this derivative for y is less than 0, and you'd have to use this one for y is what? Greater than 0. You could use either one of them for y equals 0. It wouldn't matter. But that's the reason you don't want to do this where you rewrite it. Okay? Now, somebody says, Mr. Evans, you're going to rewrite some of them this year. Yes, I am. But if you are in question of whether you can rewrite it or not, don't. All right? Did you hear that?
Mm-hmm.
If you're in question of whether to rewrite it or not, what?
You don't do it.
You don't do it. If you ever put a square root or an even root in the problem, when you rewrite it, you're going to have to do a positive version and a negative version. And we don't want to do that. Now, so far so good? Let's do it the good way. I'll do that in purple. I got purple. I saved the purple. Yeah, right there. The good way. The good way in the city is this. Take the derivative just like it's written. 2x plus 2y dy over dx equals 0. Just please remember the derivative of that 25 is what? 0. Now, rewrite it to where it's dy over dx. dy over dx equals negative x over y.
Okay, if y is dy over dx, why do you put both of them?
Of what? Talking about here and here?
Because
Okay.
like for like the other problem,
Okay.
when y was that, you just took it away.
Got to bring the 2 to the front.
Right?
Then you write down what's inside the parentheses. Is that cool?
Yes.
And then you put what out here? What's the derivative of what is inside of the parentheses?
Yeah.
Yeah.
Sorry about that.
And you're really doing that with x, except what's written out here. dx over what? dx. Subtract 2x, divide by 2y. And then if you want to know the slope here, you put a negative 3 in, divided by that positive 4, right? Let me-
So that is the slope.
Yeah. Yeah, you put the 3 in and the 4, right? Yeah, put the values in, the x and y. And sure enough, you put 3 and 4 there and you get what? Negative 3/4. Now, look what happens when you put the slope at 3, negative 4. That's going to be a negative 3, with the negative sign, right? Over negative 4. And oh, wow, we do get a slope that's positive, and we know the slope should be what? Positive. Yeah, slope should be positive.
Wait, okay. Why do you say you don't do that for x? Because the x is where?
dx over dx equals
1.
1.
So the concept of implicit differentiation itself is just where you do your like dy dx thing.
That's it.
Okay.
It's just it's dealing with the derivatives so that you don't have to isolate y by itself.
Okay.
And you're thinking of y as being a function. So when you think of y cubed, just think of a set of parentheses with a 3 above it. And that's the easiest way to visualize it.
So why is x dx over dx, but why is it dy over dx?
Okay? dx over dx. If I put 5 over 5, what do I get?
No, I understand that. I'm just saying like why is x is dx over dx, but why is this dy over dx?
Well, it's, okay, change in, okay, if you're doing the derivative, you're measuring the change in x with respect to the change in Okay, we're measuring the whole thing with respect to the change in x. So this 25 is not changing with respect to x, is it? You can put any x in there you want, you're still going to get what? 0. Right? It's not going to change. Right? This one is changing, but this one is just 2 times whatever the x value is. You change the x, you're going to get 2 times the x. The y is changing with respect to how you change the what? X.
So when you change the y, the x changes, and that's why that one.
When you change the x, the y changes. Okay? Is that all right?
Okay, yeah.
So really there is a dx over dx right here. But what is dx over
It's
dx
one.
equal? 1. And you can't do part of it with respect to x and part of it with respect to y. You're doing the derivative all with respect to x. To be honest, you can do derivatives with respect to time, or you can do them with respect to y. We just don't because it doesn't look pretty for us.
So the dx over dx and the dy over dx, that's the du part?
That's it.
Okay.
That's your derivative. That's your du part. And we just don't ever write it for the x. Now we're going to later because we're going to take derivatives with respect to time.
Gotcha.
If you were taking derivatives with respect to time, guess what? There'd be a dx over dt, and there'd be a dy over what? dt.
So how do you decide
Because
what you're
none of
taking
them
in respect to what? How do you decide that?
Well, for right now, we're just doing it with respect to x. Later on, we'll talk about particles moving with respect to time.
Okay.
You take the derivative with what? Respect to time. Matter of fact, the reason we're teaching you implicit is because our first application is going to talk about this point moving with respect to time. See, so we're getting you ready for that next step. Yeah, so your questions are good. Your questions are good because you're thinking, you know, why is the minus dx over dx written there? Now, is it pretty easy to tell you why you don't want to try to rewrite them? Because you don't want to have to do all this positive, negative parts. And that's what I didn't do when I was teaching the other day. I just showed them how the guy would mess up, and I didn't even show him how to correct it and make it right. Because you could do that, but you'd have to do positive and negative derivatives. Now, since students always go, you assigned a lot of problems that don't look anything like what's in the book. You know, so I'm going to work some problems right out of the book. 3/8, light hole, 3/8, and there we go. I will work any even problem from 12 to 18. You pick one. 12. The lady that right here that has her mask down. 12 to 18. Pick one since we can hear your voice.
14.
14.
Oh my God, I was thinking 14 too.
14. Light hole, 3.8, 14. Number 14. It says, now I'm going to go ahead and write that y to the 1/2 plus y to the 1/3 plus y to the 1/4 equals x. Now, you might have already realized that if you had to rewrite this and make it y equals, we'd be here all day trying to make that y equals. That would just be a big mess. Now, with the implicit, remember, this is implying a function. Think about it as having parentheses around it raised to the what? 1/2. So we're going to bring the 1/2 to the front. We're going to subtract 1. And then we have to take the derivative of that y with respect to x. All right? Now, let's see if y'all can do the next two. Because you're looking at a pattern. You're learning a pattern. I'm making sure I'm subtracting right. Please. Okay, so we're good with the derivative. And everybody realizes you could have put dx over dx out there, and then I told you it equals 1. What makes this really nice is notice you could factor a dy over dx out of every one of those. Yeah, so really what's going to happen is you're going to get dy over dx equals 1. And I'm going ahead and skipping a step here, because after I take the dy over dx out of this one, and this one, divide them out, I'll be left with those parts. Is it okay if I skip that step? Okay. And then you get 1/2 y to the negative 1/2 plus 1/3 y to the negative 2/3 plus 1/4 y to the 3/4. Because after I factored the dy over dx out of all that, I divided both sides by it.
No, it's not negative at the end.
Ah, very good. There's a little negative right there.
I just need to look at it for a second.
No problem. Yeah, I skipped a step on y'all. Prepping y'all for your future.
Okay.
And then somebody says, Mr. Evans, if you multiplied the numerator and denominator by y, you could get rid of these negative exponents. See, you multiplied by y here, and multiplied by y here, you would get all positive exponents if you really wanted to. I don't see a point in it, but you could. So far, so good. And notice, the x value has nothing to do with the slope. What's the only thing that affects the slope in this particular case? The y values. Okay, dy, dy, dy. I factor out the dy over x to the front. Then I take 1 and I divide it by everything in that set of parentheses.
Ah, okay.
Yes, sir.
Well, I have a question, but nothing is coming up, but
That-
I'm asking.
That takes care of it?
So, well, I'm gonna ask him anyway.
Okay.
So why could you not do like, put all of those numbers on the bottom in like a parentheses and then do them to the negative first power?
Sure could.
And then it's like they're all just on the top with.
Negative
posi-
1.
Yeah.
Now you can't put that negative 1 into all of those. You know that, right?
So yeah.
It would still be all of that in parentheses with a negative 1 above it. And then you couldn't do anything with that. Okay, you can't. But yeah, if you want to rewrite it and not put it in the denominator, you just put it all in parentheses, put a negative 1.
You can't make that wouldn't make all the other
Nope.
exponents
No.
negative. Positive. Okay.
Nope. Because you got all that in parentheses.
Okay.
If they were multiplied,
Then you can do that. Okay.
all right. And what you're probably figuring out now is that your algebra skills are going to have to really improve before we start applying this or using it. That's the reason we're doing Lighthold, is he forces you to develop your algebra skills. Now, let's look down at any one of the trig problems, 19 through 26, and I'll even work an odd one if you want to. Or I'll even go back up and work anything at the top. But I figure you want to work a trig one. No, which trig one you want to work? Miss, last name.
Richardson.
Miss Richardson. How you doing back there?
I'm good.
Tell me which problem to work.
25.
25.
It's a good looking
That's
problem.
what I was.
25.
21 personally, but.
Secant squared y plus cotangent x minus y equals tangent squared x. Now, on this, all of you have we started doing the little different colors of paper off of my desk and writing out a list of information? If I talk to y'all about that.
Yes.
We need to be doing that because y'all need those derivative rules written down, right? Now, you know that this is really all in parentheses with a big 2 above it. So we're going to bring the 2 to the front and write down the secant y. And then, so we got 2 to the front, we wrote it down to the power of 1, and now we have to take the derivative of secant y. What is the derivative of secant u?
Secant u times tangent u.
Don't tell me.
Thank you. Yes, ma'am. It's secant u, tangent u, and then you got to put what on the end? The du. dy over dx. But the rule, yeah.
I see.
And somebody says, Mr. Evans, why don't you just go ahead and put a square there? Don't do it, because it'll just mess you up, because you won't realize you did the derivative. It was 2 to the front. Write down your secant y, secant u, and the derivative of secant u is secant u, tangent u, and then you have to take the derivative of the u, and what is the derivative of y? dy over dx. Now, put your plus sign down. Cotangent u. What is the derivative of cotangent u? It is
Negative dx. Oh, wait.
negative
Negative cosecant.
squared of u, and then don't forget you have to do what to that x minus y. That's your u, so you have to put what after it? dy. The du. All right? It's cotangent u, cosecant squared u, du. The derivative of x is 1 minus the derivative of y, which is what? Dy over what? dx. Because we're taking all of our derivatives with respect to x. And then you say, Mr. Evans, we haven't even got to the other side. Yeah, equals. Bring the 2 to the front. Write down the tangent x, and then take the derivative of tangent x, which is what? Derivative of tangent x is? Secant squared x. Now, times 1, because dx over dx. Ladies and gentlemen, get those sheets. I got pretty pink, I got blue, I got purple back there on my desk. I'm not supposed to handle them and hand them to you. But get those sheets and start making your derivative rules. Because you want to be able to flip it over, look at it, and all that. All right? You want to see your derivative rules.
Can I go get one?
Yes, ma'am.
Question. So for the secant, like over here in the front, the secant squared, we like took the 2 out and then we did secant y. But then for
Hang
cotangent,
on, whoa,
right,
big power rule.
And then
2 to the front.
right,
That's inside the parentheses.
okay.
And that's the derivative of what's in the parentheses.
Right. And
Over
then-
here, there's no power up there, is it?
So that's why we just go straight to it?
Right.
Okay.
Yeah.
Okay.
You didn't have a power rule to start with. Okay?
No,
And that's the reason, if you think about this, we'll use the power rule too, because that's really all in parentheses with a what? 2 above. Okay? Now, here's the scary part.
Yep, yep. Blue.
What
Or,
color?
it doesn't matter, just not purple.
Yeah, purple's hard to see.
Yeah.
He might be trying to go out with a girl from Loyola, so you might want to give him blue.
Okay.
Could be.
Yeah. And now that there's not St. Vincent's around,
Sarah, I didn't even ask, do you want one?
That's all right.
that's all right that you thought it was fun. All right, here we go.
It's a really good day.
Now, here's the catch. If you look here, you could factor a dy over dx out of all that, couldn't you? Right?
But why?
Because I'm going to try to isolate dy over dx by itself. Now, here's the catch though. See, you can't factor it out here because